So hello guys, today we are going to solve a leetcode question that goes by the name merge in between linked list. Okay, merge in between linked list. The question number is 1669, medium level question. It's a leetcode daily question. Okay, so first I'll try to read the problem statement and then go on to the solution. Okay, so what does the problem statement says? You are given two linked lists, list 1 and list 2 of size n and m respectively. Remove list 1's nodes from the eighth node to the bth node and put list 2 in their place. Okay, so what you have to do is you have to remove list 1 nodes from the eighth node, list 1 nodes from the eighth node and the bth to the bth node and put list 2 in the place. Okay, so you have to you are given basically two lists, and what you have to do is in the first list you have to remove some nodes, and you have to put list 2 in that place, instead of those nodes. See, instead of you, if you remove this, instead of these nodes, you will be putting the other list. Okay, so you will be merging them in between, removing some nodes from between and pushing the other nodes. Okay, the question is quite simple. Okay, the blue edges and nodes following figure indicate the result. Okay, blue edges indicate the result. So this is my final array, this is my final linked list. Okay, build the linked list and return its head. Okay, I have to build the linked list and return the result. Okay, return its head basically. So if I am given an option like this, basically what the question is trying to say, if I just tell you, if this is my linked list, I'll not take the serial numbers because it might it might create some confusion. Okay, so 5, 6, 10, 15, and then 16. Okay, this is my list 1. This is my list 1. And what is my list 2? And what is my list 2? My list 2 is basically 10, 20, and then 30. Okay, and I'm given with some indexes L and R, L and R. Okay, I have to remove the nodes from 2 to 3. From 2 to 3, I have to remove the nodes from 2 to 3, such that, and I have to put the other list in between. What does it mean by that? Basically, if I just index all of the nodes, I'll simply see that these are the two nodes. These are the two nodes in the range. Basically, this is the second node, this is the starting node, and this is the ending node. This starting node and ending node. Okay, so I have to remove these nodes. Okay, I'll remove these nodes. Okay, I have to remove these nodes. So what will be my answer like? And I have to put this instead of this. Okay, so what my answer is gonna look like? My answer is gonna look like 5, 6, and then 6. My pointer would be pointing here. My pointer would be pointing at this place. So 10, then 20, then 30, and then this last position would be pointing at this place. So then 16, then 16. So this is my answer. Okay, as you can see, these two nodes are removed from the list. Okay, if I was given something like from 1 to 3, if I was given like from 1 to 3 you have to remove, so I would be removing this node also. So my first node would be directly connecting to this. And the last node would be respectively connecting to it. So all the connection like this is lost. All this connection is lost. Okay, so in that case, what my answer would be like 5, 10, 20, 30, and then 16. 5, 10, 20, 30, and then 16. So I hope the question is clear. The question is very straightforward. Okay. So how can I do this? I'll directly come to the approach. It's not difficult. Okay, I'll tell you how to do it. Okay. Basically, if you just see, if you are given a linked list like this, and I tell you, and I just number it with its indexes, and I tell you that I have to remove from index 1 to 3. I have to remove all the nodes from index 1 to 3 inclusive. So 1 and 3 will also be included in this. Okay. So I have to remove this part. If I have to remove this part, what are the nodes I should get access to? And there is some linked list I have to merge. In between. So what are the nodes I should get access to? Okay. I say that I want access to this node. I want access to this node. Why? Because the next pointer of this I have to edit and point it to the another linked list heads. Okay, I have to point it to the list 2 heads. Okay, this is my list 2 head. So I have to get access to this node. I have to get access to this node. And what are the other nodes that I have to get access to? This is the node I have to get access to. This is the node I have to get access to. Okay, so one left pointer would be pointing here, one right pointer would be pointing here. Okay, and is there any other node I have to get access to? Yes, basically this node. Why? Because I have to make again a connection. Okay, so what are the 4 nodes I have to get access to? This, this and this. If I get access to all of these nodes, okay, if I have to get access to all of these nodes, then I can simply make, I can simply, like, for getting access to this nodes, I can simply start from the head and I can continue till my r plus 1, okay, till my r plus 1, I can continue till my r plus 1, okay. For getting access to this node for the left node, I can continue till my index left minus 1, till my index left minus 1. I can continue till header, till here. Okay, I can continue till here. Okay, so I can continue till here. I will get access to the left and the right nodes by this left and the right node. This is my left node, this is my right node. Now what I'll try to do, I'll basically make the left node. This is my left node. If this is my left node, this is my left node and it is pointing to this index, it is pointing to this node. I'll simply remove this connection, okay, and I'll make it point here, okay. So my left would be pointing to, left's next would be list 2 of head, that means the head of the list 2, okay, second list, head of the second list, okay. And I can simply traverse the linked list till I get to this index, okay, till I get to this index. And when I come to this index, it was initially pointing to null, and when I come to this index, I can simply remove this connection and make it point to this index, as I already have the access to this index. It would be simple, and at last what I'll do is I'll simply return the head, okay. I'll try to do the dry run. I'll just show you by taking a test case. 10 1 13 695, 10 1 13 695, okay. And what is my list 2? List 2 is basically some big numbers. I'll just take smaller numbers. For your convenience. Like suppose I take, or should I take the same numbers? Suppose one is 10 raised to power 4, one is 10 raised to power 5. It may not match. I'm just showing you so that you can understand. Okay, there's no point of writing so big numbers. It doesn't, because it is independent of the value. Any value can be present here. Okay. So what is my first step? I have to get access. I have to get access to this. Like I have to identify my interval, what I have to remove. Okay, so my a is equal to 3, b is equal to 4. Okay, I'll mark all the indexes 0, 1, 2, 3, 4, 5. Okay, so what index I have to remove? a3, b4. Okay, a3, b4. So this interval should be removed. If this interval has to be removed, I have to get access to this node, that is my left pointer, and I have to get access to this node, that is my right pointer. I already have access to this node, that is my list 2. Okay, that has my list 2. So what I'll do is I will simply iterate till my I not becomes this a minus 1 not equal to this a minus 1. Okay, till my I is not equal to this a minus 1. Okay, till my I is not equal to a minus 1, I'll just iterate. Okay, and when I'll get access to this node, what I'll do, I'll simply remove this connection. And I'll make it point here. Okay, I'll make it point here. Till then, I'll increase my left pointer. Okay, And when I got access to this, I'll simply move the right pointer from the start to this position, because this is the ending index, because I have to merge this node to this node, right? So I have to get access to this. So this is my right node. I'll continue till it becomes equal to, till my I becomes equal to, till my I becomes equal to my b plus 1, till my I becomes equal to my b plus 1. So I'll continue till this index. Okay, when I get access to this, basically the first step would be the first basically third step. This is my first step, this is my second step, and this is my third step. Okay, third step would be merging this, because it was initially pointing to this. I'll simply merge this node to this node. Okay, basically the next pointer would be pointing at the list, at the head of the second list, so this would be pointing here. And when I will point to this, I can simply iterate to the last node. And when I come here, I can simply change the next node's value from null to this node, to the right node. So as you can see, all the nodes in between, are skipped. So what will be my modified linked list? 10, then 1, then 13, 10 raised to power 4, 10 raised to power 5, 10 raised to power 6, and then 5, Okay, so this will be my modified linked list. What we are doing? We are doing nothing. Just we are coming to the left node. We are getting access to the left node. We are getting access to the right node, because I have to remove all of these. So for removing all of these, I have to get access to the endpoints. So that I can connect both of them. So when I come to this, I'll simply make it point to this node, and I'll iterate the whole array. I'll get to the last node. When I get to the last node, I'll simply make it point to the right node. This is all I'm doing. Okay. So I'll take one more test case to explain you. 0, 1, 2, 3, 4, 5, 6. Okay. 0, 1, 2, 3, 4, 5, and 6. Okay. And what are the nodes? Some big numbers, some big random numbers that are just trying to confuse you. Okay, let me first write down my limits. A is equal to 2, b is equal to 5. I'll simply index them 0, 1, 2, 3, 4, 5, 6. Okay, so how many nodes I have to remove? From this to this I have to remove. From the second node to the fifth node I have to remove. Okay, so now I know what pointer should I get access to, what nodes I should get access to. I should get access to this node, and I should get access to this node. Doesn't matter what my linked list is, what my second linked list is. These are the nodes that I have to get access to. Okay, these are the nodes that I have to get access to. Okay. So okay. So if this is my second linked list, 10 raised to power 5, 10 raised to power 6, 10 raised to power 7, 10 raised to power 8. Okay, when I have gotten access to this node, I can simply remove this connection and make it point here, Okay, and I can simply traverse the array, linked list, and make the last node point to here. So what you will say is these nodes are automatically removed. Okay, so this is my modified linked list. We are doing nothing. We are getting access to the left and the right nodes respectively. And when I'm on the left node, I'm pointing to the head of the first node, head of the second list. I'm just traversing to the last node, and I'm making the last node point from null to this right node. Okay, so this is what I'm doing. Okay, it's a very simple approach. Get access to the left node, get access to the right node, and in this case this left would be a minus 1, this would be b plus 1, because from a to b we have to delete, and this is inclusive, so I have to get access to a minus 1 and b plus 1 respectively. What I'll do is I'll make my left of next point to the head of the second node, so it will point to list 2, and list 2's end node would point to the right. And what I'll do is I'll simply return the head. I'll simply remove the head of the first linked list. That is list 1. Because the list 1 is not modifying. Okay, the first node that was there, it is still there, it is still there. Okay, it is still there. So I'll just try to go down on my approach. What I first need is, I first need the left and the right pointer respectively, and it is, they are both, they are both pointing to the same node, they are both pointing to the same node. Okay, okay, what I need is, I'll start from 0 and I'll continue till a minus 1, because I am incrementing at, I am incrementing this at each value, I'm just incrementing it. Okay, so a minus 1, like I would be traversing till this index, I would be traversing till this index, like basically I would be traversing till this index. If I have to remove this, I'll basically traverse from this index, because it will be like pointing one more time around. So I would be ending up at this index, basically I'm ending at this index. Okay, so ending at this index. Okay, what I'll do is, this is done, so I have got access to the left node. Okay, now I have to get access to the right node. I'll move the pointer again to 0 till my like it is less than b plus 2 or b plus 1, uh, less than b, because we have to just move one place ahead, right? So it would be like, right next, I would be incrementing at this, at each point, and then what I have to do is, I have to make the left next point to the list 2's head. Okay, I'll make this left traverse the whole list, I'll make this left traverse the whole list till it has a next, till it reaches the last node, till it reaches the last node. So left would be incremented, and when it reaches the last node, it would be simply pointing to my right node, it would be simply pointing to the right node, and what I'll return is, I'll return my list 1. Okay, let's try to run it, and what we'll see if it runs. Okay, and my left exists, and my left exists. Okay, and my right exists. Basically we are just writing it down, for, so that it doesn't point to the null position. Okay, oh basically I have to increment this values. Okay, okay, we're just getting on the safe side. Okay, so what is the problem? 9 to 5 we are taking an extra node, 5 to 6 we are taking an extra node. So I'll continue till b plus 1, okay. Okay, I'll try to submit. It has been submitted successfully. Okay, so I'll just explain you the code now. I'll explain you the code what I just wrote. Okay, what I'm doing is, I'm just following my steps, what I just wrote. What is my first step? To get access to the left node. Yes, we are just allotting the nodes at first, because we need a starting point, right? Allotting the left and right nodes at start to the head, okay. Now what I have to do is, what is my first point? I have to get access to the left node, get access to the left node, basically the a minus 1th index, okay, because I have to remove from a to b. So if this is a to b, I have to get the access to this node, right? If this is my a, this is b, okay, I have to get access to this node as well as this node. So I have to get access to a minus 1 and b plus 1, okay. When I've gotten access to this, to the left node, I'll get access to the right node, okay. Then what I have to do is, when I have gotten access to the left node, I'll simply make it point from the left node to the head of the second list, okay. And this is what I'm doing at this position. Left now points at the head of the second list, okay, at the head of the second list, and I'll traverse till the end, traverse till the end of the second list, traverse till the end of the second list, end node of the second list basically. And when you have gotten access to the last node, what you have to do is you have to just point the last node to the right node, so that all these in between nodes would be skipped. It would be something like this. Okay, so all the between nodes would be skipped. So now what you are pointing is pointing the last node to the right node. Okay, so I'll just submit it so that it gets saved, and I'll share the same link with you. Okay, so this is what I'm doing. What is my time complexity for this approach? As I'm traversing once for getting the left index, I'm traversing once for getting the right index, and I'm traversing the second list also. So time complexity is somewhere around 3 into n, of 3 into n. And what is my space complexity? Is there any space extra space I'm using? No. So O of 1. Okay, time complexity is 3 into n, and space complexity is O of 1. Okay, so this was the overall solution to this question. Okay, if you have any doubts, regarding the solution, you can just ping it down in the comments. And if you have like the solution, just like, share, subscribe. Thank you.